Welcome to our lesson on the fundamental guidelines for the safe use of electricity, especially when using appliances and performing barbering services. Electricity powers our modern lives, but it also comes with risks if not handled properly. In this video, we'll break down essential vocabulary, explain how electric current works, and share practical safety measures. Whether you're a professional barber or just want to use appliances safely at home, these tips will help you stay protected and confident. Let's start by exploring why understanding electricity is so important in the barbershop environment and beyond. Have you ever found yourself in a situation where there was no electricity? It can be challenging, especially in a barbershop where nearly every tool relies on power. Licensed barbers are expected to use electrical appliances safely and efficiently, not just for their own safety but also for their clients. This scene sets the stage for why understanding electrical safety is crucial in your daily work. Let's keep this in mind as we move forward and learn how to prevent accidents and maintain a safe working environment. By the end of this lesson, you'll be able to define major terms related to electricity, describe the differences between direct and alternating current, compare electrical overloads with short circuits, and explain key safety measures. These objectives will guide us through the lesson, ensuring you gain practical knowledge that you can apply immediately in your barbershop or at home. Electricity is a powerful and essential form of energy that shapes our daily lives. In the barbershop, it's indispensable. Without it, none of the tools or appliances would function. From lighting to clippers and dryers, every aspect of barbering relies on a steady and safe supply of electricity. Understanding how electricity works and how to use it safely is not just a technical requirement, but a fundamental part of providing professional services. Let's get familiar with 10 essential terms you'll encounter in this lesson. Electricity, electric current, load, conductor, insulator, amp, volt, ohm, watt, and kilowatt. Understanding these terms will help you grasp the principles behind safe appliance use and electrical safety in the barbershop. We'll explain each one in detail as we move forward, so you'll know exactly what they mean and why they matter. Electricity is a form of energy that produces light, heat, and can cause magnetic and chemical changes. It's the invisible force that powers everything from your barbershop lights to your electric clippers. Electric current, on the other hand, refers to the movement of electricity along a path called a conductor. This flow is what allows appliances to work and is the foundation of all electrical operations. A load is any electrically powered appliance, such as a hair dryer or clipper. Conductors are materials that best transport electricity to these loads. Silver and copper are the most effective, but other metals, graphite, and even the human body can conduct electricity. Insulators, on the other hand, protect users by preventing current from passing through them. Materials like silk, wood, plastic, rubber, and glass are common insulators and are essential for safety. It's important to keep appliance cords straight and free from knots, kinks, and tangles. Damaged cords can expose you or your client to active electrical current, increasing the risk of electric shock. Always inspect cords before use and replace any that show signs of wear or damage. This simple habit can prevent accidents and ensure your tools remain safe and reliable. The amp is the unit of electric strength, indicating how many electrons are flowing through a line. Circuits in homes and shops are rated by amps, such as 10, 20, or 30 amps. The volt measures electric pressure, how hard electrons are pushed by the source. Small appliances typically use 120 volts, while larger motors may require 240 volts. Understanding these ratings helps you choose the right appliance for the job and prevents overloading circuits. Ohm is the unit of electric resistance, measuring how difficult it is for electrons to move through a conductor. The size, material, and temperature of the conductor affect resistance. Watt measures how much electrical energy is used per second. A blow dryer, for example, uses about 1,000 watts per second. When you reach 1,000 watts, that's 1 kilowatt. Knowing these units helps you understand how much energy your appliances consume and how to use them efficiently. Every electrical appliance has a nameplate that provides important information. The frequency in hertz, the voltage required 120 V or 240 V, and the number of watts it consumes per second. Some nameplates also include a UL or Underwriters Laboratories designation, indicating the appliance has been tested for safety. Always check the nameplate before plugging in a new appliance to ensure it matches your power supply and safety standards. Electric current comes in two forms: direct current DC and alternating current AC. In DC, electrons move at an even rate in only one direction. This is typical for batteries. In AC, electrons flow first in one direction and then in the other, which is the type of current supplied to most homes and businesses. Knowing the difference helps you understand how your appliances work and what kind of power source they need. Special instruments are used to change the type of current. An inverter or converter changes DC to AC, while a rectifier changes AC to DC. A rheostat is used to adjust the flow of current, allowing you to change the volume or intensity of electricity. These devices are essential for ensuring that appliances receive the correct type and amount of current for safe operation. Batteries and generators are the two main sources of electric current. A battery has a positive and a negative terminal and produces direct current only. Generators, which are most often used in barbershops, produce alternating current and use mechanical energy to create a flow of electrons. Understanding your power source is key to using appliances safely and efficiently. For electric current to flow, two conditions must be met. There must be a source like a generator or battery and a circuit, a closed path through which electrons travel. If the circuit is open, the flow of electricity stops. This basic principle is at the heart of all electrical systems, from the simplest battery-powered device to the most complex barbershop setup. A closed circuit allows electrons to flow from the source to the appliance, powering your tools. An open circuit, on the other hand, means the path is broken and electricity cannot flow. Understanding the difference helps you troubleshoot issues and ensures your appliances work as intended. Barbershops typically use parallel wiring, which allows several appliances to operate at once or at different times. In a series circuit, all loads must run at the same time, and the circuit travels from one load to the next. Understanding these wiring methods helps you plan your workspace and avoid overloading circuits. An overload occurs when more current flows through a line than it's designed to carry. This can happen if you plug too many appliances into one outlet or use a device that draws more power than the circuit can handle. Overloads can cause wires to overheat and may lead to fires or equipment damage. Always be mindful of the limits of your electrical system. A short circuit happens when a foreign conductor, like water or a metal object, comes into contact with a wire carrying current to a load. For example, dropping a blow dryer into water can cause a dangerous short circuit. This can result in sparks, fires, or electric shock. Always keep electrical appliances away from water and inspect cords for damage. To protect against overloads and short circuits, safety devices like fuses and circuit breakers are installed in appliances and buildings. These devices connect directly to the circuits in your power box and are designed to interrupt the flow of electricity if something goes wrong, preventing damage and reducing the risk of fire. A fuse is a safety device that connects directly to a circuit in the power box. It contains a fine metal wire that allows current to flow through it. If the current exceeds safe levels, the wire melts, breaking the circuit and stopping the flow of electricity. Fuses cannot be reused and must be replaced after they blow. A circuit breaker is another safety device that connects directly to the circuits in your power box. Unlike fuses, circuit breakers are reusable. When an overload occurs, two pieces of metal inside the breaker separate, breaking the flow of current. Once the issue is resolved, the breaker can be reset and used again. Proper grounding is essential for electrical safety. Two-prong plugs have two slots of different sizes and are polarized to keep current directed. Three-prong plugs add a round hole for a grounding conductor, offering the most protection. Ground fault circuit interrupters, GFCIs, are installed in areas where water and electricity might meet, such as bathrooms or near sinks, providing extra safety by quickly shutting off power if a fault is detected. Knowing how to prevent and manage fires is crucial when working with electricity. Electrical fires cannot be extinguished with water, so fire extinguishers are a must in every barbershop. Remember the PASS technique: pull the pin, aim the hose, squeeze the handle, and spray the chemical. This method can prevent injury and save lives in an emergency. Let's pause and check your understanding so far. Reviewing key points helps reinforce learning and ensures you're ready to apply these safety measures in real-life situations. Take a moment to reflect on what you've learned about electrical terms, circuits, and safety devices. Continuing with our review, let's ensure you understand the differences between overloads and short circuits and how to identify safe appliance use. These checkpoints are designed to help you internalize the most important safety concepts before moving on. Let's keep reinforcing what you've learned. Understanding the practical application of these safety measures is just as important as knowing the theory. Take a moment to think about how you would handle a real-life electrical emergency in your barbershop. This final knowledge check helps you consolidate your understanding of safe electrical practices. Remember, being proactive and prepared is the best way to prevent accidents and ensure a safe working environment for everyone. Congratulations on making it this far. Validating your learning is an important step. Take pride in the knowledge you've gained about electrical safety and remember to apply these principles every day in your barbershop or at home. Safe practices protect you, your clients, and your business. Let's take a moment to review what you've learned. Understanding the basics of electricity, the importance of safety devices, and the correct use of appliances are all key to maintaining a safe and efficient barbershop. Reflect on these lessons and think about how you can implement them in your daily routine. Thank you for joining this lesson on electrical safety in barbering and appliance use. Remember, knowledge is your best defense against accidents. Stay informed, stay alert, and always prioritize safety in your work. With these guidelines, you're well equipped to create a safe and professional environment for yourself and your clients.